Quantum. Now this word is going to be common. Even we heard that word in Marvel movies.
Quantum entanglement stuff.
What does it really mean? Before understanding quantum computing, let's understand what is quantum first. Well, quantum is an invisible world where things behave in the ways that are seemingly impossible. This is the world of quantum. Unlike the everyday world around us, where objects obey the laws of classical physics, the quantum world operates according to its own set of rules. In this strange world, particles can exist in multiple places at once, communicate instantaneously over vast distances, and solve problems beyond the reach of even the most powerful classical computers. Isn't it look like a movie like Ant-Man? Well, it may sound like a science fiction, but the incredible potential of quantum technology is very real. Now let's understand it in a more logical way. Quantum is a term used in physics to describe the fundamental behavior of matter and energy at a very small scale, such as the scale of atoms and subatomic particles. At this scale, matter and energy can exhibit strange and unexpected behaviors that are not seen in the classical world. Quantum mechanics is the branch of physics that studies these behaviors and provides a mathematical framework to describe them. Quantum computing is the application of quantum mechanics to the field of computation, which allows for the creation of the powerful new algorithm that can solve problems that are currently considered unsolvable even by supercomputers. So buckle up and get ready to take a quantum leap into the mysterious and exciting quantum kingdom. Now let's understand what is quantum computing. Imagine you are solving a jigsaw puzzle, but instead of using one piece at a time, you can use all the pieces simultaneously. That's the power of quantum computing, a revolutionary technology that can solve complex problems exponentially faster than classical computers. Quantum computing relies on the principle of quantum mechanics, where subatomic particles like electrons and photons behave in the ways that classical physics can't explain. By harnessing these unique properties, quantum computers can manipulate data in a fundamentally different way than classical computers. The potential applications of the quantum computing are vast, from optimizing supply chains and drug discovery to revolutionizing cryptography and climate modeling. Now let's learn classical versus quantum computing, how they are working. Well, classical computers is like using a bicycle to get around, while quantum computing is like traveling through space on a rocket ship. The differences lie in the way they process information. Classical computers use bits, which are either 0 or a 1. These bits are like switches that can be turned off or on. A series of bits can represent complex information, but it is still operate on a binary system. Well, if you want to know more about how classical computers work, then you can let me know, or you can read about number systems, like how classical computers are processing the information, how they are giving the information. They are working on binary number system. Well, quantum computers use qubits, which can represent both 0 and 1 at the same time. Thanks to the principle of superposition, it's like having a light switch that can be both on and off at the same time. This means that quantum computers can process vast amount of data in parallel, making them incredibly powerful. Another fundamental principle of quantum computing is entanglement, which allows two or more qubits to be connected in such a way that their states become correlated. This allows the creation of algorithms that can solve problems that would take classical computers millions of years to solve in just seconds. Well, we all are doing multitasking on our computers, but they are actually not doing multitasking. They are dividing all the tasks in the parts, so they are working simultaneously. However, quantum computers can do multitasking at the same time, like qubits can be present at multiple places at the same time. So this is the major difference between quantum computer and the classical computer. Now let's learn in more detail how quantum computers work. To manipulate the qubits, we use quantum gates, which are the building blocks of the quantum circuits. These gates are responsible for changing the state of qubits based on input they receive. Some examples of quantum gates includes the Harmonic gate, which places a qubit into superposition, and the C0 gate, which entangles two qubits. Quantum algorithms, on the other hand, are the instructions that guide the quantum gates to perform the specific task. On such algorithm is Shor's algorithm, which can factorize large numbers exponentially faster than classical algorithms. To put this into perspective, imagine a classical computer trying to find the factors of a number with 100 digits. It would take millions of years to solve this problem, while the quantum computer with the Shor's algorithm could solve it in a matter of minutes. There is no doubt technology is growing really fast. It means it can break all our security layers. Well, quantum computers have the power to break many of the encryption methods used today. However, quantum computer can also be used to create new and more secure encryption methods that are virtually unbreakable. Quantum computing is still in its early stages, but it's already being used by companies like Google and IBM to solve complex problems in the fields such as finance, healthcare, and energy. And as the technology continues to evolve, the possibilities are truly limitless. Quantum computing may sound like a science fiction, but it is very real, and who knows what kind of world it will create. One thing is for sure, the future is quantum.